Hi everyone, let's talk about onion skin or insulation weathering. So onion skin is a physical weathering process. The reason why it's called insulation weathering is because it requires sunlight, which is also known as insulation. So here are the steps laid out, 1, 2, 3, 4, 5, 6, and we can always reflect this on a diagram. So step 1, during the day, the surface of rocks absorb a lot of heat. So let's draw a daytime diagram. So the sun, and then a rock. So the surface absorbs a lot of heat. You can draw the sunlight going in and the surface. You can just draw that. The reason why it absorbs a lot of heat because the rocks are kind of dark color, so they have low albedo and therefore they absorb a lot of heat, and they are poor conductors of heat. So the heat doesn't go inside the rock or doesn't go down; it just stays on the outer layer. And due to this absorption of heat, the outer layer expands. So you can draw an outer layer like this, the rocks expanding. But then during the night, so you draw a nighttime diagram. You can split this in half. Draw a nighttime diagram with the moon. The surface radiates the heat because there's no light, there's no sunlight going in, there's no insulation. You get your rock here. It is the one now giving out the heat. So you draw heat going out. And because it's losing temperature, it's getting colder, it starts to contract. So you can draw an inner lining like this and draw arrows to show that it's contracting. And you need the presence of water for onion skin weathering. So you don't really have to draw another diagram, but you can if you want. Just draw the rock itself with differential expansion, because if you get a bit of coating of water over here, a bit of coating over here, then some of the water will take in the heat and evaporate itself. So there's lower temperatures in these areas. So these areas will expand less than these areas. So you get like this. So the expansion and contraction will be really weird with the presence of a bit of water. And because of this differential expansion, there's differential pressure exerted everywhere, and eventually the outer layer of the rock, so this part, will crumble into sand and stuff. So this is how onion skin or insulation weathering works. So let's move on to our favorable conditions of onion skin weathering. So you need extreme temperatures and fluctuations of temperatures. So as you see on step 1 and step 3, you can have the you need a lot of heat to expand, and you need less heat to let the rock radiate more heat out. So having extreme temperatures means that the more heat that it can absorb, then the more heat that it can radiate out. And you need fluctuations, so you can't just have one period, 6 months of hot temperatures. That means the rate will be quite slow because it's not expanding and contracting as frequently. And you need little precipitation. As you can see here, you need a bit of water to cause this differential expansion and pressure stuff. But if you have too much water, then you get the entire rock coated with water, and then that just diminishes the effects of temperature. The whole rock will expand almost the same way, and therefore you don't get this differential pressure, and it diminishes the effects of onion skin weathering. So that sums it up for onion skin weathering or insulation weathering. I hope you guys enjoyed this video.